When we find the arc length of a function like y equals mx plus b, we take the integral square root the sum of 1 plus dy dx squared from a to b to get the arc length. This will be similar when we're finding the vector length, but instead we will do dx dt squared plus dy dt squared plus dz dt squared, take the sum, square root it, and the integral from a to b. We get each component from the given, and it can be in two forms, either in these arrows or in this formula right here. And we'll take the derivative, square it, and then add them. There is no limit to how many components of a vector, but you do the same thing for each additional component. An introduction problem to this concept would be finding the length of a vector defined by all constants. To do this, we would just square each constant, take the sum, and square root that sum to get the length, which would be, for this problem, 8.83176 units. If we were to implement variables, we would have to take the derivative and then integral the square root of the sum from a length to a length. For this problem, we have to find the length of vector r, which is 2, t, 3 times t to the 3 halves. We'll start from 1 and go to 2. R prime is 0, 1, 9 halves times root t. Then we plug in the values, so it's integral from 1 to 2 square root of 0 plus 1 plus 9 halves root t all squared dt, which will give you 5.5765 as the length of the vector. Here we see constants and variables, and you still take the derivative and the integral. For the first problem, we will find the arc length of vector r from 4 to 5. We begin with finding the derivative of the vector by taking the derivative of each component separately and then plugging them into the equation, which is the integral from 4 to 5 square root of x 4 cosine t squared plus y 1 squared plus z, which is negative 4 sine t squared dt. After doing the work, you will get root 17. This is the other way a vector can be written as, with the x component multiplied by I added to the y component multiplied by j added to the z component multiplied by k. If we had more components, we would add them and multiply them with the next corresponding letter. For this problem, we will be going from 0 to 1. We will still find the derivative of each component separately and plugging them into the equation the same as we would from the format before. After doing the work, you will get 6t multiplied by 1 plus t squared in parentheses. To find this, you would do parts and get 9/2. For number 2, we want to find the length of the arc, that is where e to the x equals 1 over cosine y, and the plane z equals 2 if y equals c intersect, from t equals 0 to t equals pi over 3. From this we can get x equals negative ln cosine of t if y equals t and z equals 2. We can write the vector as negative ln cosine of ti plus tj plus 2k. The vector prime is tan ti plus j plus 0. From this, we can get the integral of 0 to 3 pi over 3 square root of tan t squared plus 1. If you continue this, you will get 1.317.